Wanted to put together a video for you from 1.7 when we talked about solving absolute value equations. Uh, First off, the definition here for an absolute value is the distance from 0 on a number line. So if I actually draw a quick number line right here, and I put 0 in the middle, and let's say I just put 3 here and -3 here. The absolute value, which you know is the bars here, the absolute value is the distance. So if we count the distance from here to here, we know that the distance is 3. And we also know that if we have the absolute value of -3, well, the distance from 0 to -3 is also 3. Now, the easy way to remember that, again, is whatever's inside the absolute value bars, you get a positive number. So here we have the absolute value of -2, that equals 2. The absolute value of 5, that equals 5. So that's the quick definition and understanding for the absolute value. Now, to start solving equations, we need to make sure we actually set up two cases when we do this. So what we're going to do is we have the absolute value of x plus 5 is equal to 8. So case 1, what we do here, case number 1, we're going to drop the absolute values. And we're going to say, all right, x plus 5 is equal to the positive 8, and then we're going to take case 2 and we'll set up another equation. Again, the inside stays by itself, so x plus 5, and that is going to equal -8. So we have one of them equal to the positive and one of them equal to the negative, or whatever's on the other side of the equal sign. And then we solve it just like we've been solving here for the last couple sections. We'll subtract 5 from each side, and we'll wind up with here x is equal to 8 minus 5. We'll get 3, and then we'll subtract 5 from this side, and we'll actually wind up with, again, x is equal to 8, -5. We get -13. So we actually have two answers. It's x equals 3 and x equals -13. Very easy to double check. We're actually going to put 3 back in here for x. 3 plus 5 is 8. Absolute value of 8. You get 8. Put -13 in here. -13 and 5 is -8. And the absolute value of -8 is positive 8. So let's look at another one to kind of help us out here. Again, we've got the absolute value of x minus 6 is equal to 10, and we'll set this up in here again as case 1. We'll have x minus 6 is equal to, and we'll use that we're equal to positive 10. And then over here we'll set up case 2, where we will have x minus 6 is equal to a -10. So again, we drop the absolute value and we set one of them equal to the positive answer, one of them equal to the negative answer, and we solve. So we're going to go plus 6 on both sides. Here we'll have x is equal to 16, and then plus 6 here and plus 6 here. And we'll wind up with x equaling a -4. And again, the two answers, so we have x equals 16. So again, double checking here real quick. 16 minus 6, that's 10. Absolute value of 10, we get 10. -4 and -6, that winds up being the absolute value of -10, and the absolute value of -10, we get 10 again. All right, so let's look at some different types here. First of all, when we solve these, we got to make sure that the absolute value bars are actually by themselves first. So right now we see the absolute value of x plus 3, and then we have the addition of 4, and that equals 12. Before we can set up our two cases, we need to make sure that we get rid of the 4. So we subtract 4 from both sides first. And when we do that, then we'll have the absolute value of x plus 3, and that equals 12 minus 4. We get 8. And we can set up our case 1, we wind up with x plus 3, that's going to equal a positive 8. And then case 2, we'll wind up with x plus 3 equaling a -8. Solving this again by subtracting 3 from both sides using the inverse operation, we'll wind up with x is equal to 5, and subtract 3 here and subtract 3 here. We'll wind up with x equaling negative 11. And again, going in back here and you're checking your answer, plug in 5. 5 plus 3 is 8. Absolute value of 8 is 8. 8 plus 4, you get 12. Negative 11 and 3 is negative 8, and the absolute value of that, again, is going to be 8 plus 4, you get 12. Notice this example over here. The absolute value is not by itself. We're going to get rid of the 6 here. By the inverse operation, I'm going to add 6 to both sides, and that'll get the absolute value by itself. So that'll cancel. We'll be left with x minus 4, absolute value, is equal to 6 and negative 5. That's going to be positive 1. We'll set up our two cases here. We'll wind up with x minus 4, and that's going to equal positive 1. I'll choose red again. And then case number 2, we'll wind up with x minus 4 equaling negative 1. All right, so let's do our simple math here. We're going to go plus 4, plus 4. X is going to equal 5, and plus 4, plus 4. X is going to equal 4 negative 1. That's going to be 3. Again, plugging it in, you'll see that the equation actually winds up being true as well. And let's see if we can keep going, do some more examples here. Yeah, so if we look over here, we're going to talk about the no solution case. Since we know that the absolute value has to be positive, whenever we have the absolute value already set equal to negative, there's no way that whatever we put in the absolute value is going to be negative. This is just going to be no solution. So if we talk about something like this, if I had the absolute value of x is equal to 4, well, what two numbers could be in here? Well, we know that 4 and negative 4 got to be our answers to get 4. But because this is already set equal to a negative answer, that's why we're getting a no solution case. If we look at this one and we set this up, all right, well, just like the previous examples, absolute value is not by itself. So I'm going to subtract 2, subtract 2. And let's see what happens when I subtract 2. Well, the 2 and the negative 2 cancel, and I can't forget to bring this negative down, so I got a negative 2x minus 5. Absolute value is equal to 7 minus 2. We get 5. Absolute value is still not by itself, so I'm going to actually divide this side by negative 1. Then I'll have 2x minus 5, absolute value, is equal to negative 5. Now, here's what should be flashing out at you right now, is that we have an absolute value that's set equal to a negative number. We cannot have that. There's no such thing. We know that, again, whatever we put in an absolute value has got to be positive. So because this absolute value is set equal to a negative, we have a no solution case for this. Okay? Moving on. We have a word problem with absolute value. A lot of times this happens in the business world. We have a manufacturing problem here. A quality control inspector at a bolt factory examines bolts that come off an assembly line. Any bolt whose diameter differs by more than 0.04 millimeters from 6.5 millimeters is sent back. So we can be 6.5 plus 0.04 or 6.5 minus 0.04. So we're going to write an absolute value equation to find the maximum and minimum diameters that we're allowed to have for these bolts. This is an actual simple absolute value equation. So we're going to have x minus 6.5, and that's got to equal 0.04. So again, if we set up the two cases, case 1 is going to equal x minus 6.5 is equal to 0.04, and case 2 is going to equal x minus 6.5 equaling negative 0.04. So doing this, again now, when we set up, we're going to wind up over here with now adding 6.5 to both sides. So x is going to equal 6.5 plus the 0.04, and we're going to wind up with 6.54. for an answer. Let me erase that so you can see that a little bit better. So 6.54 we'll get for that one. We'll add 6.5 here. And so we'll have here x equals 6.5, and then adding that with a negative 0.04 or subtracting 0.04. Well, here we'll wind up with 6.46. So now what does this mean? This means that the bolt can have a maximum of a diameter here of 6.54 millimeters, or it can have a minimum of 6.46 millimeters. So there's a great word problem there that shows how to solve an absolute value as well. So hopefully this quick video reinforces what we learned in section 1.7 for solving absolute value equations.